Something huge is happening, mostly behind the scenes, but it's at the very heart of the AI revolution. We're seeing a fundamental split in the world of computing. You see, AI isn't just about new software. It's forcing us to build an entirely new kind of place, the AI Gigafactory.
To really get this, we have to understand that AI is making us tear up the old blueprints and completely rethink what a data center even is. We're shifting away from a one-size-fits-all model to something incredibly specialized.
Okay, quick thought experiment. When I say the words data center, what image pops into your head? For most of us, right? It's this huge, windowless building packed with rows and rows of humming server racks. It's where our emails, our websites, all our company data lives. And, you're not wrong. But that picture is becoming yesterday's news fast.
This right here, this is the heart of the Great Divide. The best way to think about it is this. A traditional data center is like a general-purpose workshop. It's got a huge collection of tools. A hammer, a saw, a drill, ready to handle thousands of different, smaller jobs. The AI data center, though, that's a gigafactory. It's built for one reason and one reason only, to produce one single, incredibly complex thing, like a huge AI model, at a scale that's just hard to wrap your head around.
So you might be asking, why do we even need two different kinds of factories? Why the split? Well, it all boils down to the type of work they're designed to do. The job itself defines everything, from the machines inside to the very walls of the building.
Let's look at that work. The old-school workshop is built for lots of different predictable tasks. Think about your company's HR system, its databases, its websites. They're all separate jobs, and they're pretty straightforward. The AI Gigafactory, on the other hand, is designed for one single, monstrously complex job: training an AI model. This isn't a bunch of small tasks happening one after another. No, this is one giant computational problem that needs thousands of processors all working together, in parallel at the exact same time.
To really make this click, just look at these examples. A traditional job is like running the monthly payroll. It happens on a schedule, it's important, but the computing power it needs is pretty modest. Now compare that to training a model like GPT. That is a job that can run 24/7 for weeks, sometimes months, chewing through trillions of calculations on a huge, perfectly coordinated fleet of machines. It is a completely different animal.
And this number really tells the story. To get that one massive job done, all the parts inside the factory have to talk to each other at unbelievable speeds. We're talking about 1,000 times more data flying around inside the building. And why? Because in an AI gigafactory, the only thing more expensive than your power bill is having your super expensive processors just sitting there, waiting for data. Every single microsecond is money.
All right, so let's put on our hard hats and take a quick tour inside this AI Gigafactory. We're going to look at its core parts, the machines, the assembly line, and the warehouse, and see just how different they are from that traditional workshop.
First up, the machines themselves. Traditional data centers run on CPUs, central processing units. They're the jack of all trades, pretty good at a whole bunch of different things. But AI data centers, they run on specialized accelerators, like GPUs and TPUs. These things are specialists. They are designed from the silicon up to be brutally efficient at the one kind of math that powers all of modern AI. Just one rack of these things can outmuscle hundreds of racks in a traditional setup. Next, let's look at the assembly line, which, for us, is the network. In a regular data center, most of the data traffic is what we call north-south. It's flowing from the servers out to you, the user on the internet, and then back again. But in an AI data center, almost all the traffic is east-west. It's the constant, high-speed chatter between thousands of GPUs all working together on that one massive problem. This requires a totally different kind of network, like a multi-lane superhighway built exclusively for traffic inside the factory. And finally, the warehouse. This is where the raw materials, the data, are stored. Traditional storage systems are fine if one or two machines need to grab data at a time. But an AI training job, that's like having thousands of workers all trying to grab materials from the exact same shelf at the exact same time. To stop that from becoming a total traffic jam, AI centers use something called parallel file systems, which are built for that exact scenario. Extreme, simultaneous access to feed those hungry GPUs without any delay.
Okay, so when you pack all this specialized, high-octane power into a single building,
you get some pretty serious physical consequences. We have to talk about the two huge challenges that really define the AI Gigafactory: power and heat.
This chart lays out the first massive problem: power. A normal server rack might pull about 10 kilowatts. But look at this. An AI rack is easily pulling 40, and the really dense ones can hit 100 kilowatts. That's 10 times the power packed into the same space. And all of that electricity, it has to go somewhere. It turns into one thing: an incredible amount of heat.
And that heat creates a brand new cooling problem. For decades, we've cooled data centers the same way, with giant air conditioning units that just move a lot of cold air around. And that works fine for a 10 kilowatt rack. But for a 100 kilowatt rack, air simply cannot pull the heat away fast enough. It's like trying to put out a bonfire with a desk fan. The solution? You have to move liquid. And that is a fundamental seismic shift in how these buildings are designed.
And this isn't just a theory. Check out what Google is doing with its AI accelerators. They literally dunk their computer hardware into a special engineered fluid. The fluid boils at a low temperature, and that boiling action carries the heat away from the chips. The results are just incredible. They cut their cooling energy by 42%, they can pack 3 times more computers into the same space, and the chips run faster because they never get hot enough to slow down.
So you take all these technical shifts, the custom hardware, the extreme power demands, the liquid cooling, and it all adds up to a completely new economic reality. So let's look at the bottom line.
This chart tells a really powerful story. Look, building a traditional data center is already unbelievably expensive. But building an AI data center? It's on another planet. Just look at the cost per square foot for the power and cooling infrastructure. It's 3, even 4 times higher. You're not just building a room for computers anymore. You're effectively building a small power plant and a sophisticated chemical cooling facility that just happens to have computers in it.
And if you really want to feel the true scale of this, listen to this quote. A single one of Microsoft's AI facilities can pull down 80 megawatts of power. That is enough electricity to power a town of about 65,000 homes. These aren't just data centers anymore. They're becoming major pieces of our national energy grid.
So this is the great split. On one side, we have the reliable, familiar workshop, and on the other, this incredibly powerful but unbelievably demanding AI gigafactory. The rise of this new kind of factory, with its voracious appetite for energy and resources, it really leads us to the most critical question we have to ask ourselves as this tech continues to scale. AI promises to change our world, but at what cost to our planet? Thanks for joining us for The Explainer.